Okay, we're in loans and investments, but now we're doing something called a shifted geometric with its long run value. Okay, what the heck is that talking about? Well, you know what a geometric is, right? It's just something you multiply by the, in the middle of the sequence, you have a multiply there. Well, this is shifted geometrics, means you're multiplying and you're adding, or you're multiplying and you're subtracting. We've actually already done that. But really, it's more about the long run value. So you'll understand what a shifted geometric is, and you'll be able to find a long run value. All right. Diet sodas have more caffeine than regular soda. I did not know that. That's kind of cool. So 46 milligrams of caffeine compared to 34 milligrams of caffeine. 30% more. Interesting. Okay, another interesting note. Did you know that coffee has way more caffeine than pop does? A lot of people think, oh, Mountain Dew or a coffee's like this. No, coffee's like way, way more. And then some of those crazy, like Starbucks things, are talking like 300 milligrams compared to 46. Yes?
Oh, my mom bought her chocolate coffee beans, and they had to have a warning on the package because like 3 coffee beans was equivalent to a cup of coffee.
Oh my gosh.
Yeah.
Chocolate covered coffee beans, like 3 beans is equal to a cup of coffee. Yeah, you eat a whole bunch of those things, you could have major headaches or whatever. All right. A long run value. The sequence or a function approaches. That's a limit. Sorry, I didn't read the word in the beginning. A limit is a long run value that a sequence or a function approaches. Okay. Now, I would like you to picture it in a graph. If my function's doing this, do you picture it all of a sudden stopping going up? Isn't it just going to keep going up? Then that one has no limit. Does that make sense to you? It's not going to stop. Okay, now if, on the other hand, I have one that's going like this, it's going up, but it's leveling off. Do you get how something like that might have a limit? I know some of you might think that that's not possible, but there is a limit to some functions. There's an asymptote line up here. It'll get closer and closer to that, but it'll never touch it. You'll see today you can have a function that goes up, but eventually will stop going up. It'll level off, and it won't go any higher. Okay? In pre-calc, we learned about special functions like this too, but for today, we're just going to be taking some of your functions we've already been doing and showing you that if you tweak it just right, you can make a function where it'll go up a certain percentage, but then level off and stay like stable. All right. The following are shifted geometric sequences. Each formula has a long run value or a limit. Algebraically find the long run value and confirm it using a calculator. Okay. Now here's the thing that's really important to understand about this. If I'm in the long run, if I'm way out on a graph, like way, 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 way over here, then u sub n and u sub n minus 1 are pretty much the same thing. You get, if I have a point here and I have a point there, they are so close to each other. In the scope of, like, if you go infinitely in the sequence 2, 4, 6, 8, dot, dot, dot. If this is u sub n, and u sub n minus 1 is the number right in front of it, do you get, as you go to, like, even numbers that have, like, 20 digits, okay, and then the next even number that's just too bigger than that they are, relatively speaking, incredibly close together, considering how big they are? It's like 2 billion is an even number, right? And then 2 billion and 2. Relatively speaking, aren't they really close? I mean, if you were like, yeah, I'm Bill Gates, I got $2 billion, and you're like, well, I got $2 billion and $2, it'd be, oh, come on, they're pretty much the same thing. That's exactly what you do mathematically, is you say that these two numbers are pretty much the same thing. So how do I do that algebraically? I'm going to go back to this guy here and say, if this and this are pretty much the same thing in the long run, then I'm going to call this x, and I'm going to call that x. What I did, I just called that x and I called that x. Am I cheating a little bit? Yeah, because they're not exactly equal to each other. But in the long run, they will be incredibly close to each other, so close that you could say they're about equal. All right. So if that's true, now it's just a simple math equation to solve. That's it. You just have to solve an equation. I get x's on both sides, you subtract the smaller one. Do you remember that? So I'm going to go minus 0.5x, minus 0.5x. This does confuse people sometimes. This is 1x minus 0.5 of an x. That's like a whole x minusing a half of an x. It's 0.5x. And these, of course, are opposites, so they're gone. Equals 16. And then I just divide by 0.5. And x is equal to 16 divided by a half. 32. Really, that's like 16 divided by 1/2. And you remember how I did fractions over fractions with you? That's to remind you of, at this exact moment, that you're supposed to flip and multiply the bottom one. So I changed this to times and flip this. 2. So 16 times 2 is 32. That means this function right here, if you put it in your calculator and you look at it in the long run, it levels out at about 32. All right, let's prove it. Everybody take your calculator and put that puppy into your calculator. Let's see if it really does. I'll pause for a second while I do that. Okay, so we're checking this one on the calculator. And boy, it looks like it's leveling off around 79.9. I'm guessing it goes to about 80. Raise your hand if you had about 80 as your answer. Okay, good. And again, algebraically, how we can see that is this is x equals, and what's that? 0.75x plus 20. Subtract 0.75x from both sides. You have 0.25x equals 20. And then you divide by 0.25. X equals 20 divided by 0.25. That's really 1/4. 20 divided by 1/4 is like times 4. So it's 80. So its long run value is 80. And again, can you imagine a situation where this could actually happen in real life? The dollars, where you want your dollars to level off, you want to keep about, let's imagine for a moment that you want to keep about $1 million in the bank. Okay, and you're putting in some money every month because, I don't know, you're still trying to keep your nest egg alive, so you're adding something to it each month. But you are taking a certain percentage of it out, like you're taking some percent out. All right, now, in the real world, there's another way you can make a shifted geometric. But there's a lot of ways you can make them not work. All right, let me show you this one. U0 equals 25. Do you remember me saying that the starting value does not matter? Remember when we solved the equation, you never put it in, so it didn't matter. Okay, and if you have un equals un minus 1 times 1 plus 0.5, that's a big growth, 50% growth, right? And then I add 12 to it every month, or sorry, every year. Do you get this is only going to up and up and up and up? So this one, you could still do that little process and it would tell you a number and it would be completely wrong. Because you have to know when there is a long run value and when there's not. This one's growing and growing even more. To get that the other ones, they have to be like doing the opposite things. They have to be fighting each other. Okay, the other ones had one of them minus and one of them plus. All right, let's see if, think about it this one. What if they were both minus? It's dropping 50%, and then you're subtracting 12 every year. Do you think that would level off somewhere? No, it doesn't make sense. It would eventually go to 0, right? All right. In fact, it would go to a negative number eventually, because it would eventually you'd run out of money, and then you're still subtracting 12 each time, right? In fact, it would go to a negative infinity. If we graph this one, again, we start at 25, so it starts here, and then it would go down like that. No limit on it. All right. So again, you could put it in your calculator and see, you know, go to u sub 100 and see where it's at, and it's just going to be negative and still going down. All right. Actually, let's do that one quick because there was confused looks on that one. Maybe I'm wrong. All right, we're going to go minus, let's just make it a little simpler, 0.25 instead of 0.5. 1 minus 0.25 and then minus 12. Start with 25. Okay, get this in your calculator, please. You're going to compare with the kid next to you in a minute, just in case one of the two of you messes up the numbers. And then we're going to subtract 12 here at the end. And now we'll look at the table. Now if I go to u sub 22, we're at negative 47. It's starting to level off at 47 there. Maybe it's not negative infinity. Trying to think of what, oh, I know why. It's dropping 25%, but if you're at a big negative number, what that's doing is putting you closer to 0. So it starts pulling this percentage here, starts pulling it back towards 0, and this number keeps dropping it a little bit, and then it keeps pulling it back towards 0, and then it drops it, and then it levels off. So if we were to graph this one, it does start positive, but it would end up doing one of these. It would have a long run value. It would have a long run value that's negative. All right. So if they're both negative, new news. Probably have to record a new video for next hour because I started with the wrong assumption there. Glad I checked. So this kind you could solve using the algebraic method, and it would have showed you, like, I assume it goes to negative 48. I don't know if anybody went further down, but okay. All right, so if they're both positive, though, that will grow to infinity. I can guarantee you that one. If they're both negative, it'll turn. How about, let's see, the only other options are if one's positive and one's negative. All right, so let's try the kind where it's, let's make this an investment of $100,000. And let's make it growth, like 8% growth in the stock market. But then you're subtracting an amount every month. Like if with your 100,000, maybe you want to be able to take out $500 a month, and see if that would level off somewhere. All right, so let's go into my calculator, put in 100,000 here, going up here, 8% growth. I don't think I'm taking out enough to make it level off. Or would it ever level off? 0.08. All right. All right. This one, double checking here. All right, this one is I've got a loan set up. And I have a minus in there. Okay, my bad. This you'd have to think of as a loan to yourself, I guess. Plus, all right. I had a plus in there, or a minus in there instead of a plus. Okay, definitely not limiting though. It's going up, 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 up. Okay. Now, if we subtract just the right amount, I wonder if it would. How much a year is that growing? That's growing 8%. 8% of 100,000 is 8,000. That means to me, if I subtract 8,000, I bet it would work. Let's try it. Change that 500 to an 8,000. And then go to the table. Look at that. Stayed exactly the same. Every year you gain 8% and then you take 8% out. It makes sense. You'd get your money back again. All right. What if you wanted to grow a little bit and then start taking out? Well, that would get more complicated because then you don't want to take any out at the beginning. You want it to grow first and then you can start taking out 8,000 a year. Okay. All right. Enough. I've talked it to death, but I wanted to kind of explore it with you on the calculator. So let's look at example 3. You see how this one has the graph's already here for you? Just look at it. Does it look like it's got a long run value? No, just infinity. It's going to go to infinity. How about example 4? Does that one look like it has a long run value? Nope, just continues forever. And what was this one? This was a plus and plus, and I warned you on a plus and plus that this thing's always going to just grow to infinity. All right? On a plus and a minus, the only thing you can do is that one example I showed you where you can make it level off, okay, if you force this number. But all right, so what we're really looking for is, and here's another plus with a minus, it's also not having a limit. Okay, what were the kind that actually had limits? Minus on the inside and a plus on the outside. Or a minus minus, you're right. So really that means anything where there's a decay rate. All right, so bottom line, after checking all the options, it has to be decaying, like it has to be a number 1 minus something. 1 minus something. If it's decaying on the inside, then we should be able to find a long run value for it. All right, so what does your homework look like? It's going to be problems like that, surprisingly enough. So let's everybody find your homework. And it says long run values. And I'm going to use download file. Okay. For each sequence, find the values of u sub 1, u sub 2, and u sub 3. Basically, that's the first 3 terms. Identify the type of sequence, arithmetic, geometric, or shifted geometric. Arithmetic just means you're adding something. Geometric means you're multiplying by something. And shifted geometric means you're multiplying by something and then subtracting or adding. That's the kind with the loans. Loans and investments are shifted geometrics. All right. So on this first problem, all we got to do is figure out the first 3 terms. By now, if you can't do that with your calculator, that'd be really sad. Okay, so you can put that in the calculator and tell what u sub 1, u sub 2, and u sub 3 are. Notice it's u sub 0 is the first term. So they want not really the first 3 terms. The first term is 25. They want the next 3 terms, I guess you'd say. All right. Identify the type of sequence. Okay, well, this one's just adding 8 each time, so it's a geo. And tell whether it's increasing. Wait a minute. Geo, it's not. So somebody should stop me there. Adding something each time is arithmetic. Sorry. And increasing, decreasing, or neither. Well, if you're adding something each time, it's definitely increasing. Okay, so this was arithmetic, and it's increasing. And that's all there is to it. You just got to find the first 3 terms. Actually, it's the second, third, and fourth term. All right. Those are obviously really easy. Let's go on to, and because they're so easy, why don't you skip D as in donkey? We'll skip one of those at least. Okay, number 2, find the long run value. This is, there's 2 ways. It does not say here that you have to find them algebraically, but I need to tell you that because if it didn't on the test, just put it in the calculator and it would tell you what the long run value is. You just go down go down your chart far enough and it says what it is. You have to do it algebraically on the test. So I'd like you to say algebraically after it. So then remember, your starting value doesn't matter. I don't care. What I care about is I take an x for the first thing and an x for the second thing, because in the long run, those 2 terms are super close to each other. And this actually can be subtracted. It gives me 0.8. And this one doesn't have any, it's not a shifted geometric. Now, if you think for just a second, what in the long run, if this thing is shrinking by 80% and we're not adding anything to it, in the long run, what's its long run value? 0. Good. And if we had solved it algebraically, you'd get 0. Let me show you. Subtract 0.8x from both sides. This side becomes 0, and the other side becomes 0.2x. You divide both sides by 0.2. 0 divided by 0.2 is just 0. X equals 0. So you can still just solve the equation and it'll tell you the answer. Long run value, 0. Okay, this guy just doesn't matter. X and X. So I'm going to subtract now 0.75x from both sides because that's what this is right there. Subtracting 0.75x, subtracting 0.75x. And now these 2 are gone, and I have 0.25x equals 25. Now you divide both sides by 0.25, and you'll have your answer. Dividing by 1/4, we're dividing by 0.25, is the same as multiplying by 4. All right, you've learned how to find a long run value, and this is supposed to be kind of an intro to limits. You start limits in pre-calc, and then you totally learn limits in calc. All right, let's go a little further and see if there's any other kinds. Ooh, extension. Assume 2 terms of a sequence are u sub 3 is 16 and u sub 4 is 128. Find u2 and u5, basically the ones in front of it and the one after it, if the sequence is arithmetic. Meaning, you got to think now, if the 2 numbers, if it's arithmetic, that means what? They're adding. How do you get from 16 to 128 with adding? Must be adding a big number each time, right? So then logically you can figure out if this term is 16 and this term is 128, the question is what was that term and what was that term? If they were adding something each time. Well, then obviously you can go backwards to figure out that one and go forwards to figure out that one. And same idea if they're geometric. All right, they have a small pool and are doing a chlorine treatment. It's a real world problem. I like this. Did you guys know this? I actually am the one who looked this up last year. Chlorine in a pool is a good example of decay because the chlorine, just the sunlight shining into your pool makes the chlorine disappear. If you give it enough time, you'll have no chlorine left in the pool because the sunlight will make it decay. All right, so basically, it doesn't decay instantly, it decays at a percentage. So that's why you can figure out how much to add each time, each week or each day or however you want to do it. You can add a little chlorine to your pool at just the right rate so it comes to a long run value that you want. If your chlorine is too strong in your pool, have you guys ever heard of that where somebody's chlorine was too strong and somebody went swimming in there and their hair like turned orange? Yeah. So if the pool water is not strong enough in chlorine, then you can catch nasty like diseases and stuff from the, basically, you wouldn't want to swim in water that like little kids have, sneezed in and everything if it didn't have something in it to kill the germs. That's what the chlorine's trying to do. Although there is a new trend towards saltwater pools, which I think is fascinating. Um, have you heard of anybody in this area who has a saltwater pool? Yeah, some people are nodding. It's a little more expensive, I think, because it's a new thing. But it's kind of a cool idea. You don't have to have the chemicals on it. It's simply salt, and it's like the ocean. The ocean doesn't need chlorine, right? So the ocean is salt water. It's sort of like trying to replicate the ocean in your pool. I don't totally understand how it works, so I won't try. But anyway, so in the chlorine, in the long run, you want it to level off. You want some chlorine, but you don't want too much. So you want it to level off like this by you adding a certain amount each month. So it ends up being a cool example of this in the real world. There is such a thing as a shock treatment of chlorine. Basically, that's like putting in a ton of chlorine at once, and you're not supposed to swim in it for a while after the shock treatment, and then it kind of mellows out a little bit. And the shock treatment basically is when there's something bad happening in your pool. You got to put in a whole bunch. So we're exploring what happens if you put in a whole bunch and then you got to put in some each day after that to make it go away. Remember that number at the beginning doesn't really matter, the starting value. So you put in that shock treatment eventually in the long run, that doesn't matter. All right. And that's all I have for you for today.